Good morning, students. Today we are going to discuss few numerical as well as a left out topic, that is your connected motion. Now the numerical which we are going to discuss, number one numerical, is from the exercise itself, from the chapter laws of motion. So let me read out what is in the question. A constant retarding force of 50 Newton is applied to a body of mass 20 kg moving initially with a speed of 15 meter per second. How long does the body take to stop? So you have to find out time. Initial speed is given 15 meter per second, mass is given 20 kg and force applied is your 50 Newton. So as the force is retarding force, that's why we are going to use this equation F equal to minus ma. So F is your 50 and mass is your 20 A. So A comes out to be your 50 by 20 minus sign. So it's your minus 5 by 2 meter per second square. So acceleration is your minus 5 by 2 meter per second square. Negative acceleration means retardation. Now the formula which you are going to define is your equation of motion v equal to u plus at. So final speed is 0 because it is asked how long does the body take to stop. So v equal to 0 and u is given 15 meter per second, that is your initial, and acceleration with the negative sign we have got minus 5 by 2. So minus 5 by 2 t. Now if you simplify, u equal to 5t by 2. So u is given here 15 meter per second. So 15 we have substituted. So t equal to 15 into 2 by 5. On simplification we will get t equal to 6 seconds. Now next numerical which we are trying to define here, it says that a body of mass 5 kg is acted upon by perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration of the body. So two forces 8 Newton and 6 Newton, and the angle between these two forces is your 90 degree as per the question. Acted upon by perpendicular forces. A body of mass 5 kg is acted upon by perpendicular forces 8 Newton and 6 Newton. So the simple diagram we have drawn, two forces F1 vector and F2 vector. They are at 90 degree perpendicular. So you will get the resultant force F using the parallelogram law of vector addition. That is your R equal to root over a square plus b square plus 2ab cos theta. So theta is your pi by 2 because two forces are perpendicular. So F equal to root over f1 square plus f2 square. You will get the third term goes to 0 because cos pi by 2 is your 0. So f1 we have considered 8 Newton and f2 we have considered 6 Newton. So 8 square plus 6 square. So you will get 64 plus 36. It's your root over 100. So it comes out your 10 Newton. So resultant force is your 10 Newton and the individual forces are 8 Newton and 6 Newton. Now as per this diagram, the magnitude of f1 vector is nothing but is your f cos theta if you take the component. So we have used this one, f1 equal to f cos theta as per the diagram. So f1 is given 8 and f is given 10. So cos theta equal to 8 by 10. So it comes out here 4 by 5. So theta equal to cos inverse of 4 by 5. So this is the direction of the force and magnitude of the force is your 10 Newton. Okay. Now the direction of the force gives the direction of the acceleration, because if you take F equal to ma, so F is your vector quantity and acceleration is also vector quantity. So direction of the force gives you the direction of the acceleration because mass is a scalar quantity. Now if you have to define the magnitude of the acceleration, so you have to use the value of mass, and the value of mass as per the question given here, how much? 5 kg. So you can write here also F equal to ma. So in place of F we will write 10 and mass is given here as per the question. It is your 5 kg, 5a, so it comes out to be your a equal to 10 by 5, that is your 2. Therefore a equal to 2 meter per second square. So as per this one, you can define the magnitude of the acceleration, and direction of the force is nothing but the direction of the acceleration, because we are going to use this equation. If this one is vector and this one is vector, because this is your scalar, so direction of the force is nothing but the direction of the acceleration. And for magnitude of the acceleration, you can use this equation directly. F equal to 10, already we have defined here, and mass is your 5, so 5a, so a comes out to be 10 by 5 is your 2, so a equal to 2 meter per second square. So we have got the magnitude of the acceleration, and the direction of the acceleration is your cos inverse of 4 by 5. Okay, because direction of the force and direction of the acceleration is same, because F equal to ma. If F vector is vector, F vector is your, F is your vector quantity and a is your vector, then definitely a is your vector quantity, because mass is a scalar. Now next topic which you are going to define is your connected motion. So you see, it's a pulley, and over the pulley you have passes an string, and on the string ends you do have two masses. One is your m1, whose weight is x vertically downward, and another mass is your m2, whose weight is x vertically downward. M2 greater than m1, so that's why the system moves up with acceleration a and gets down with acceleration a. Now there is a tension in the string, and the tension is nothing but some kind of force which causes due to the weight. So T is the tension, and tension also depends on the property of the string, material of the string basically. So tension T is there, so you have to write the equation as the system is moving up on the left hand side. So T minus m1g equal to m1a. So this is your number one equation. And on the right side, the system is getting down, so m2g is nothing but the weight, m2g minus t equal to m2a. So 1 plus 2 gives you m2g minus m1g equal to m1 plus m2a. So g, m2 minus m1, so m1 plus m2a, so a is equal to m2 minus m1 by m1 plus m2g. So this is the acceleration of the system, by which the system one side is moving up and other side is getting down. Now you can find the tension T using this equation 3 and 1. So if you substitute 3 in 1, you will get T equal to m1 a plus g. So m1 we have taken out, and within the bracket we have substituted a. So a is your m2 minus m1 by m1 plus m2, and plus 1 we have written because we have taken out g outside. So if you take the LCM, m1 plus m2, m2 minus m1 plus m1 plus m2, so minus m1 plus m1 goes off, so it's your 2m2. So m1g 2m2 by m1 plus m2, so it's your 2m1 m2 by m1 plus m2 g. So this is the tension experienced on the string, and this is the acceleration by which the mass scrolled up and getting down. So these formulas are very important for the numericals, and few numericals we are going to check out in our next class. So please, if you have any doubt, put your doubt. This is a simple equation and simple mathematical calculation. So more we'll do next class. Please check it out and try to find out your doubts. Thank you.